Hello everyone, this is Praveen Sharma, Physics Mentor. Welcome back to the NEET Physics Crash Course 2026. So this is the lecture 8 of the series in which we will cover the PYQs of the chapter Motion in Plane. So let's start. First, pause the video, read the question carefully and then have a look at the solution, isn't it? So here in this question, it is given that velocity of swimmer with respect to water, or you can say velocity of swimmer in still water is 20 meter per second and velocity of river is 10 meter per second, isn't it? Now the condition given in the question is that there is a river flowing towards east. I am drawing the top view of the river. This is east, west. This is the north bank of the river and this is the south bank of the river. There is a swimmer who wishes to cross the river by following the shortest path. So, by starting from the south bank, when he starts swimming, he may reach here, he may reach here, he may reach anywhere on the other bank, isn't it? But he has to follow the shortest path. So, the path will be shortest when he reaches the point B on the other bank, exactly opposite to point A, isn't it? So, this must be perpendicular to the direction of flow of the river. Except this path, if you measure the distance of all other paths, it will be greater than the path AB. So, the condition, as per the condition given in the question, we can draw a conclusion that the path of the swimmer must be perpendicular to the direction of flow of river, so that this path AB is perpendicular to direction of the flow of river. Only then the path will be shortest. So, how he can achieve this? So, to reach the point exactly opposite to point A on the other bank, the swimmer should take his strokes by making some angle with this line AB. Let us suppose this angle is theta. Now, this is the velocity, or you can say this is the velocity due to his own effort, that is velocity of swimmer with respect to river. Now, this velocity will have two components, definitely. One along the line AB and other along the direction opposite to the direction of flow of the river, isn't it? So this velocity will be given by, this is VSR sine theta because it is its component VSR, and this is VSR cos theta. Now one more thing, the velocity of the direction of river is given as 10 meter per second towards east. So this is the velocity of river, that is 10 meter per second towards east, isn't it? Now the swimmer is acted upon by the three velocities. These are the two components of the velocity VSR. VSR is the velocity of the swimmer due to his own effort, isn't it? And VR is the velocity of the river, which continuously pushes the swimmer along east direction, isn't it? So for shortest path AB, these two velocities, that is VSR sine theta, must be equal to VR. Why? Because VR, velocity of the river, has the tendency to move the swimmer along this direction, that is direction east, and the component of the velocity VSR, that is VSR sine theta, has the tendency to move the swimmer along west direction. But if you wish to find the shortest path, then you will reach exactly opposite point. Then the swimmer must not move neither to the east nor to the west. He must reach exactly the point opposite to point B, isn't it? What I am saying, I am explaining it further. Suppose if VR is having more value than VR sine theta, then the tendency to shift right side will be more than the tendency to shift left side. Then the swimmer will reach the point right side to the B, that is somewhere here, here, here and here, isn't it? Now if VR sine theta will have more value than VR, then swimmer will reach point left to the B. So we will not require those conditions, because any other point except B, the path will not be the shortest. We have to find the shortest path. The shortest path will be AB. It means that the VR should exactly be equal to VR sine theta, so that swimmer neither moves right side nor moves left side. He just reaches exactly opposite point to the point A. So this condition must be fulfilled. So here, from here, sine theta is given by VR by VSR. Since VR is 10, VSR is 20, so 10 by 20 is 1 by 2. So theta is equal to 30 degree. Now this 30 degree is having the direction of 30 degree towards west. So this is the answer will be 30° west, isn't it? So this is the question. Now next question is, the two bullets are fired horizontally. Again, in every question, just pause the video, read the question carefully, and then look the solution, isn't it? So in this question, it is given that there are two buildings 100 meter apart. So I'm drawing the building. Let us suppose this is the ground. This is the ground, and there are two buildings on this ground with the same height, and the height is given as 200 meter. Height is given as 200 meter. The distance between the building is, this is 100 meter. The height of the building is given as 200 meter, and the condition given in the question is that the two bullets are fired horizontally. It means that the two bullets must have the velocity, the component of velocity, that is along horizontal direction. Both have the same velocity, and the velocity is given by that is 25 meter per second. So here we have 25 meter per second. So remember, this is ux, that is the initial velocity, component of initial velocity along x direction. Let us suppose this is x direction. And if we talk about uy, that is the initial velocity along y direction, let us suppose I am taking the vertical direction as y direction. So this will be 0, my dear friends. Why? Because it is having only the initial velocity along the horizontal direction. So there will not be any component perpendicular to this horizontal direction, isn't it? That is uy is equal to 0. Same is the case with the second bullet. Ux is equal to 25 meter per second and ui is equal to 0. So magnitude wise both are same. Now what happens? All the conditions of this bullet are being same. That is, they fired horizontally at the same time, from the same height, with the same velocity. So what happens? Within the given time interval, they must cover the same distance because everything is same, isn't it? So what happens? Suppose, let us suppose after time t, they are meeting at some point here. So the journey of first bullet like this one, the journey of second bullet like this one, because once the bullets are being fired, then they are under the influence of gravity only, isn't it? And since they are under the influence of gravity alone, so they must follow the parabolic path, and this is the case of projectile motion. So we consider that at somewhere point A, they meet at some point A. Now, as per the condition given in the question, the total distance is 100 meters. So this distance must be 50 meters, because as I say, everything is same. So the distance covered by the bullet for the given time interval must be same. So if the bullet from, let us suppose, this point Q, from the building Q, reaches or covers 50-meter distance along horizontal direction, then the same distance must be covered by the bullet which is being shot by or being fired by the building P from this direction, isn't it? Because the velocity of both the bullets are being same. So this distance, dear student, this distance is 50 meter. So this distance is also equal to 50 meter. So taking the consider the motion of any bullet, what you get? Considering the x direction, we are considering motion along x direction. So along x direction, what happens? The speed is 25 meter per second, and the time, let us suppose I am taking after time t, the both bullets meet at point A. So 25 into t, that is speed into time, this must be given by the distance covered, that is equal to 50. So why I am taking 25 meter per second as constant? Because in projectile we have one assumption that the horizontal component of velocity will, remains constant, because there is no air resistance. We take air resistance as negligible. So the acceleration only acting in such cases is the acceleration due to gravity, and there will be no horizontal acceleration. So this velocity will be constant. So by solving this, we get t is equal to 2 seconds. It means that the two bullets meet after t is equal to 2 seconds, or you can say after 2 seconds, or at t is equal to 2 seconds, the two bullets meet. So the first part of the question we have got, that is when. Now the second part, let us suppose this distance is y, so we have to find y. Now I am taking the equations or motion or considering along y direction. So along y direction, as we know that uy is equal to 0, acceleration is acceleration due to gravity, and which is given here at 10 meter per second square. So the applying the second equation of motion, we have y is equal to ut plus half at square. So the term ut will become 0 because of uy. So this will be half g is 10, t is 2. So 2 gets cancelled and y is equal to 20 meter. So the height, so this y will be 20 meters. So this height is, that is 200 minus 20 meters, that is 180 meters. So the option is after 2 seconds at a height of 180 meters. So this is the solution. Now next, given that a ship A is moving westwards with a speed of 10 km per hour. So let us suppose the initial position of ship A and B. So let us suppose here it is ship A and here it is ship B. Both are having the velocities, that is the velocity, the ship A is having velocity 10 km per hour towards north, and the velocity of ship B is 10 km per hour towards west. Let us suppose after time t, the two ships reaches the position, the ship A reaches the position A dash and the ship B reaches the position B dash. So the distance between the two is given by the line A dash B dash, and let us suppose I am assuming the distance as x. So we have to find the time after which this x becomes minimum. So dear students, let us first analyze the situation that the initial distance between the A and B, it is given as this is 100 kilometer. And if I say that the ship A covers some distance in time t, so that distance must be given by speed multiplied by time, that is 10t, because the speed is uniform. Similarly, the distance covered by the ship B is also 10t. Now, if you observe this triangle, triangle A dash, B dash and B, it is forming a right angle triangle in which this x is a hypotenuse. So, by using Pythagoras theorem, x square is given by this is 10t, this whole distance is 100. So, this much distance, that is A dash B, is 100 minus 10t. This distance from A dash to B, this is 100 minus 10t. So, this is 100 minus 10t square plus the distance, this one is 10t square. So this is x square is equal to, this is 100 minus 10t square plus this is 200t square. Now to find the minimum and maximum value of any function, we have maximum and minimum differentiation. Just to go through the lecture of that maximum minimum in the differentiation. So what happens here, x is a function of t, x depends on t, we have to find the time at which this x becomes minimum. So ultimately we have to find, differentiate the value x, the function x, and then put it equal to 0. So this is the procedure of finding the minimum or maximum value. In this question we have to find minimum. So first of all, what we do, we differentiate this expression. So this will be 2x dx by dt is equal to, now there is bracket functions, first we have to differentiate this, that is 200 minus 10t, then the linear function is there minus 10t, so its differentiation will be minus 10 plus 200t. Now what we do, that dx by dt is equal to this 1 by 2x is equal, this is 1 by 2x, and within bracket we have this is minus 20, 100 minus 10t plus 200t. Now we have to find the minimum value of x, so we put dx by dt is equal to 0. So finally we have, this is minus 20, here it is plus 20, this 1 by 2x shifts to the right side becomes equal to 0. So taking minus 20 outside, I mean common, we have this minus 20, this is 100 minus 10t, and this is minus 10t is equal to 0. Now again this 100 minus 20 into this value is equal to 0. So 100 minus 20, I am taking the value under the bracket. So this will be minus 20t is equal to 0, implies that t is equal to 5, and that will be in hour because we have taken the units kilometer per hour, and isn't it? So the answer is B. The answer is option B. So you can have the screenshot if you want. So this is, now next question. So in next question, it is given that a body is moving with velocity 30 meter per second towards east. So let us draw the condition. What is given? A body is moving with some velocity towards east. After 10 seconds, its velocity becomes 40 meter per second towards north. So this is east, west, north. So the velocity becomes like this, that is 40 meter per second towards north. So I'm writing here, this is 30 meter per second. This is 40 meter per second, isn't it? The average acceleration of the body is given by. So average acceleration of the body, so average acceleration is actually, if I write a vector, so this is v vector minus u vector by time interval. So here the delta t is given as 10 seconds. So this will be v minus u divided by 10. So this is the a acceleration. So what is so this is the subtraction of vectors. So we have to subtract the vectors v and u, isn't it? So just wait a little bit. I am taking this diagram here somewhere here. So the diagram is like this one. Here it is 40 meter per second. This is vector v. This is vector v. This is vector u. This is vector u. Moving towards east, moving towards north is vector v. That is final velocity, initial velocity. But we have to add the two vectors, that is v plus of minus u by 10. So since u is having direction towards east, then minus u must have direction towards west. So the its diagram will be like this one. This is v, and since the direction of u is from left to right, therefore the direction of minus u is from right to left. So this is representing minus u, this is representing vu. So as per the parallelogram law, there the angle between the two is 90 degree. So the v or minus u, if you add these two, then you will have the resultant you'll have the resultant like this one by using parallelogram law. I am drawing it roughly. So the diagonal, this is given by, this is v minus u, isn't it? So here we have to find its magnitude only. So this magnitude is of this one is given by, if I wish to find magnitude, then this will be v minus u by 10, where v minus u, by following the rules of parallelogram, is equal to root over this v square plus u square, and that is given as 30 square plus 40 square. So this is the special case of triplet 30, 40, 50. So this will be 50 kilometer per hour or meter per second. So magnitude wise a is 50 by 10, and that is given by 5 meter per second square. So this is the answer, isn't it? 5 meter per second square. Option C is the correct answer, isn't it? So next question, the two-dimensional motion of a particle described by, this is position vector, it is given as. So we have to find the path of the particle is parabolic, elliptical, periodic, simple, harmonic, these are, isn't it? So let us, I am writing the equation of, position vector is given as I plus 2 j cap a cos omega t. So this will be like a cos omega t I cap plus 2a cos omega t j cap, 2a cos omega t j cap. These are the things given, dear student. So if you observe, we generally write the position vector as x I cap plus y j cap. There is some x coordinate and y coordinate. So here, this is the general form of equation of position vector. So here x is, if you compare these two equations, then here x is a cos omega t and y is 2a cos omega t. Y is 2a cos omega t. So this a cos omega t is nothing but x. So here we have the relation y is equal to 2x. It means that the curve of this, the xy curve, if you plot the graph, then you will have a straight line because y is equal to 2x. That is a linear function of x. So the option, these two options, parabolic path will not, elliptical path, these two options will be eliminated. Now you are left with this two, that is y is equal to 2x. Now periodic or simple harmonic. Now keep patience. Now what happens now, since observe carefully, the x is a, if you observe the x, that is sinusoidal function a cos omega t. So this x is following, this is actually following SHM. So the x coordinate changes as per the relation SHM. So it is like the x, the values of x first to go to positive maximum, then minimum, minus side, then 0. It is following the sinusoidal curve, as as you will get, as you have learned in the SHM motion. Similarly, the value of y, this is also sinusoidal function, so this is also follow the SHM motion. That is the value of y coordinate of the particle will vary as per this sinusoidal curve. So since their x coordinates and y coordinates both are varying according to this sinusoidal curve, that's why this will form a SHM motion. And it is very interesting, the SHM motion, the form will be like this one. This is the line of y is equal to 2x. So the particle will oscillate along this line, isn't it? So its motion or the shape of the path is a straight line, but at the same time its motion is such that it is oscillatory. I mean, it is following the SHM motion. Why? Because its x coordinate and y coordinates varies according to the sinusoidal function, isn't it? So the option is, it is simple harmonic. And since any motion which is simple harmonic must be periodic, all simple harmonic motion are periodic, but all periodic motion need not necessarily be simple harmonic. But here, since it is sinusoidal function, so the motion is simple harmonic, and since it is simple harmonic, it must be periodic too. So the option is option D, that is 3 and 4 only. So in such question, if it is given some more options, like suppose straight line, then straight line will also correct, because the path of the motion here is straight line. Next. The displacement time graphs of two moving particles make angles of 30 degree and 45 degree with the x-axis as shown. The ratio of their respective velocity, as we know, v is equal to dx by dt. So dx by dt is nothing but slope of displacement time curve, isn't it? So ratio of velocity is, suppose here 30 degree and first is 30 degree and second is 45 degree. So velocity of 30 degree divided by velocity of 45 degree is given by slope. So what is slope? This slope is nothing but tan theta. We have learned in the basic maths lectures. So this is tan 30 by tan 45. Tan 45 is 1, tan 30 is, so this will be 1 by root 3 is to 1. So on further solving, this will be 1 is to root 3. Multiplying both side by root 3, we get 1 is to root 3. So option C is the correct answer. A car starts from rest and accelerates at 5 meter per second square at t is equal to 4 seconds. So let us understand. Car starts from rest, isn't it? So initial velocity of the car is initial velocity is 0. At time t is equal to 4 seconds, let us find its velocity. So this will be as per first equation of motion. So this will be u is 0 plus acceleration is 5 and time is 4. So v is equal to 20 meter per second. So this is the important information we got. Now at t is equal to 4 seconds, a ball is dropped out of window by a person sitting in the car. Suppose I am sitting in the car, and listen, if the car is at rest, then if I drop this marker, then it will follow a straight line path and falls into the ground. But what happens if I am running, or you can say I am sitting in a running car which is running at some velocity, and from that car if I drop this marker, then the marker will follow this path. Why? Because at the instant the marker leaves my hand, will have the velocity of my hand, and since my whole body is in the car, so whatever with the velocity of the car will be the velocity of my hand. Suppose at the instant t is equal to 4 second. No, don't suppose that at t is equal to 4 second, velocity of car is 20 meter per second. We have found it. So at the instant it drops a ball, I mean passenger inside the car drops a ball. That ball is leaving the frame of car, so it must have the velocity of the frame, that is velocity of the car, and the velocity of the car at that instant is 20 meter per second. Therefore, the velocity of the ball which is being dropped have the velocity 20 meter per second. So at the time the ball is being dropped, it is having velocity ux is equal to, this is 20 meter per second, and since it is dropped, it is not thrown, so its vertical velocity, that is ui, is equal to 0. Now what is the velocity and acceleration of the ball at t is equal to 6 seconds? Now dear students, at t is equal to 6 seconds, so once it is being dropped, and after that this ball is under the influence of gravity alone, and that's why it follows, suppose here it is ground, it follows a parabolic path, and it is a case of projectile motion. So in such questions, first of all go through the options. Without solving you can find the answer, because at t is equal to 6 seconds you have to find, it means that at t is equal to 4 second, na, this ball is being dropped at t is equal to 4 second. So at t is equal to 6 second means after 2 seconds from the time where at which it is dropped. So after at t sec is equal to 6 second, it is somewhere here, let us suppose this is point a, and at this point it is under the influence of gravity alone. So the acceleration acting on the ball is acceleration due to gravity only, and that acceleration due to gravity is nothing but 10 meter per second square. So how many options can you see where the acceleration is given as 10 meter per second? There is only one option. So without solving you will find, that is, the acceleration due to gravity is 10 meter per second square. Now what if there are two options having the same, that is acceleration, that is 10 meter per second square? Then you have to solve this question, isn't it? So velocity, you have to find the velocity. So at t is equal to t second, I am drawing its diagram. The ball will have two velocities. One is the velocity along x direction, and second is the velocity along y direction. So again I am saying the velocity along x direction is same as the initial velocity 20 meter per second, because as we know in projectile the horizontal velocity is considered as constant, because we assume that there is no resistance, and the vertical velocity vy, so this will be find out by using the first equation of motion, that is uy plus at. So since ui is 0 here, so this will be g into t, isn't it? So g is 10 and t is, since after being dropped its journey time is 2 seconds, because at t is equal to 4 second it is being dropped, and we have to find its velocity at t is equal to 6 seconds, that is 2 seconds after it is being dropped. So t is equal to 2 seconds, so this will be 2, and this vy is given by, that is 20 meter per second, isn't it? So actually it is being asked velocity. So here vy, that is velocity, component of velocity along y direction is 20, component of velocity along x direction is 20. So the ball at t is equal to 2 seconds is having two velocities, and both are having same value, that is 20 meter per second, and here it is 20 meter per second. So the net velocity is given by, this is root over a square plus b square plus 2ab cos theta, that is resultant vector is given by. So resultant velocity is given by 20 square plus 20 square plus 220 into 20 cos theta. Angle between these two components is 90 degree. So what happens, that term cos theta term will be 0. So this will be v is equal to 20 root 2 meter per second. So the option, there is only one option, 20 root 2 meter per second, 10 meter per second square, isn't it? So you can have a screenshot if you wish. Next question. A particle moves in xy plane according to rule x is equal to a sine omega t, y is equal to a cos omega t. So whenever you are seeing now sine theta, cos theta, so square it and then it, you will get what I am saying. If you add x square plus y square, then this will be a square sine square omega t plus a square cos square omega t. Now what happens, taking a square as common, you will left with sine square omega t plus cos square omega t, that is equal to 1. So this is a square. So dear friends, this is nothing but equation of circle, where a is representing the radius of the circle. It means that the x and y coordinate are such that if you square it and then add those values there, that is, you will get the same value, that is constant a square. And this is the equation of a circle, x square plus y square is equal to r square. So it will follow a circular path, isn't it? So that's all for this question. Next, listen, you have to know the equation of circle, equation of straight line, equation of hyperbola, and equation of parabola, isn't it? Now, next question, when an object is shot from the bottom of a long smooth inclined plane. So let us first draw, let us suppose this is, so this is here, it is ground, and let us suppose this is inclined plane. Yes. And one object is being shot, है ना? One object is being shot from, so let us suppose I am drawing, this is object, it is being, so here this is object, it is being shot from the bottom of the plane. Let us suppose this angle is theta. So we have to find that there are two conditions given in the question. So let us first analyze this situation. What happens when an object is being shot from the bottom? Let us suppose this is A. So what happens? It moves like this, and finally at some point B, its velocity becomes 0. Here its velocity is 0, and at this point, at the highest point, this velocity is 0. Let us suppose this distance is given by x. So applying the equation of motion in the direction of inclined plane, we have what we have. So here initial velocity is, let us suppose this is u, final velocity is 0. Acceleration is, let us first find acceleration. So acceleration is g in this direction, this angle is theta. So this angle is theta. So this will be component g cos theta, and the component of acceleration parallel to this plane is g sin theta. So what happens now, in the line of motion, the acceleration is g sin theta, but it is acting opposite to the velocity. So we will take it minus of g sin theta. So using the, you can use the third equation of motion, because that doesn't contain time, and here we don't require time. So from third equation of motion, that is 0 square minus v square by, or you can say v square minus v square is equal to 2as. So a is minus g sin theta and displacement is x. So this minus minus gets cancelled, and you will have x is equal to u square by 2g sin theta, isn't it? So we have to find the ratio x1 is to x2. So in both the cases, now we have analyzed the situation. In both the cases, only one thing is being changed, that is theta. Rest of the things, u is same, g is same, isn't it? Only one thing is changing, that is the angle theta, because it is given same object is shot with the same velocity. So what happens here, from here we have x is inversely proportional to sine theta. So if I wish to find x1 is to x2, x1 is to x2, or you can write x1 by x2, then it will be sine theta 2 by sine theta 1, because it is having inverse relation. So x1 is in numerator, so theta, sine theta 1 must be in denominator. So the first angle here, it is given as 60 degree, and the second is 30 degree. So second is sine, this is sine 30, and this is sine 60. So sine 30 is 1 by 2 divided by sine 60 is root 3 by 2. So this is 2 by root 3. 2 gets cancelled, so this is 1 by root 3. So the option is 1 is to root 3, option B. Next question. Two particles A and B move with constant velocities v1 vector and v2 vector. At the initial moment, their position vectors are r1 vector and r2 vector. So let us suppose their initial position vector, here it is some r1 vector, here it is some r2 vector. This is object A, this is object B. At the initial moment, their position vectors are r1. So this is the initial position vector of object A, and this is the initial position vector of object B. The condition for particles A and B for their collision is, so they are colliding now. They are colliding means they meet at some point, isn't it? So by applying the concept of relative velocity, this is its initial position, this is final position. So if they collide, then they must travel a distance which is given by delta r vector, because initial position, final position, so the object must approach. There is a concept of relative motion. So if you want that object A meets object B, then this must follow this path, unless how it can reach the particle b na. So this path and the time given as to reach that path, let us suppose that time is delta t. So what happens, dear friends, this delta r is given by, or you can say if you follow the triangle law, this is r1 vector plus delta r is r2 vector. So delta r is given by r2 vector minus r1 vector. So this delta r, if you think, so this is nothing but the initial distance or initial displacement or initial change in position between the two particles. So by applying the concept of relative motion, what is the initial distance between two is, that is delta r, or you can say initial, I mean the change in their position vector at time t is equal to 0 is delta r. So this must be equal to the relative velocity of object A with respect to object B. So the object A is having relative velocity, let us suppose this is v1 vector minus v2 vector multiplied by the time is t. So this is delta r. We have to write velocity of object A with respect to object B, that is v1 minus v2. This is the concept of relative motion, where what we do, we take just initial gap between the two objects, that is delta r in this case, and then we take the relative velocity, that is the velocity of approach of object A with respect to object B, with what velocity the object is approaching the object B. So this is the velocity of approach multiplied by time t. So this delta r is r2 vector minus r1 vector is equal to v1 vector minus v2 vector multiplied by time t. So here in option, if you observe, here we have r1 minus r2. So multiplying both side by minus 1, so we will have r1 vector minus r2 vector is v2 vector minus v1 vector multiplied by time t. This is equation number 1. Now if I take it, if I write this equation but in the form of magnitude, by representing magnitude, so what will happen, this will be r1 vector minus r2 vector, its magnitude is equal to v2 vector minus v1 vector, its magnitude multiplied by time. This is equation number 2. Now dividing equation 1 by equation 2, so we will have r1 vector minus r2 vector by mod of r1 vector minus r2 vector is equal to v2 vector minus v1 vector by v2 vector minus v1 vector, and time in both the equations, the time gets cancelled. So we have the option A, isn't it? So this is the concept of relative velocity. Next question. A particle is moving such that its position coordinates are 2 meter 3. So initial position, if I write r1 vector, so this is xi cap plus yj cap, this is 2i cap plus 3j cap. 6 meter per meter at time t is equal to 2 second, and then 30 meter 40 meter at time t is equal to 4 second. Average velocity vector from t is equal to 0 to t is equal to 5 second. Always remember, dear students, in finding the displacement, you require only the two positions, that is initial position and final position. Intermediate positions, it has nothing to do with displacement, is nothing to do with the intermediate positions. It only requires initial and final position. So initial position is at time t is equal to 0 and final position is at time t is equal to 5 seconds, because we have to find average velocity in between 0 and 5 seconds. So this is the initial position vector at t is equal to 0, and this is the final that at t is equal to 5, which is given by 13 I cap plus 14 j cap. 13 I cap plus 14 j cap. So V average is given by, V average is nothing but change in position vector, that is r2 vector minus r1 vector divided by time interval, that is 5. So this is 13 I cap minus 2 I cap, that is 11 I cap plus 14 I cap minus 3 I cap, again 11 j cap divided by 5. So this will be 11 by 5 I cap plus j cap. This is the answer, average velocity. The velocity of projectile at the initial point is, listen, what happens is 2 I cap plus 3 j cap. So here now, if I draw in the figure, so this is, these are the two components again, and here these are the two components. So what happens here, the velocity is 2 I cap, it means that 2 meter per second along x direction, because I cap, this is x, and this is 3 meter per second along y direction. So these are the initial velocities. Now what happens in projectile, the horizontal velocity, that is the horizontal component of the velocity, remains unchanged, because we assume that the air resistance is negligible, isn't it? So this will not change. So at final point as well, the initial velocity will be 2 meter per second. But since initially the particle is moving upward, but while returning journey it is having downward direction. So as per the law of conservation of energy, this must be equal to 3 meter per second, isn't it? Why? Because air resistance is negligible, and there is only one force, that is gravity, that is conservative force. So energy must be conserved. So total kinetic energy at this point must be equal to total kinetic energy at this point. And if this horizontal component is same at the 2 points, then vertical component must also be same. But the direction will be different, but the speed will be same. So here the option is like 2 I cap along x direction, but 3 meter per second is along negative y direction. So this will be minus 3 j cap. This is j cap. So 2 I cap minus 3 j cap, option C. Next. A particle starting from the origin moves in a straight line in xy plane. Its coordinates at a later time are root 3 3. The path of the particle means with the, since it is given that it is the particle is moving in x direction, it is given that this is x, and the motion of the particle is particle is starting from the origins, from somewhere here it is starting, somewhere here it is starting, and then in a straight line in xy plane, its coordinate at a later time are root 3 3. So its initial position O, final position A, coordinates are root 3 3. It means that this is x coordinate, so this distance is root 3, this distance is 3. We have to find path of the particle makes with the x-axis and angle. So this is the x-axis, and we have to find this angle theta. So this tan theta is given by 3 by root 3. So this is root 3, implies that theta is equal to 60 degree, isn't it? This is the solution. Next question. Two particles A and B are connected by a rigid rod AB. The rod slides along perpendicular rails as shown here. So these are the two perpendicular rails. So this rigid, this is the AB rod, rigid. So what happens? The this end of the rod, end B, and this is the other end of the rod, that is end A, which is at the bottom. So when this rod slides, this B moves downward and the A moves right side. So this is one of the questions related to constant motion, where the motion of one point is connected to the other, isn't it? Two motions cannot be separated. So here the velocity of A and B are also connected. So dear students, here we are given that the velocity of A to the right is 10 meter per second. So this is given 10 meter per second. We have to find the velocity. Let us suppose this is velocity B, this we need to find. Now this is 60 degrees, so this angle will be 30 degree because it is 90. So what happens in such question? There is a shortcut. Shortcut you can't say, but there is an understanding that what happens now. Here the velocity of this point is here something like this. Velocity of point A is here and velocity of the point B is here. The actual direction of velocity is here. The end B slides downward, the end A slides. So along this direction, this velocity will have the component. So let us first, this is 10 meter per second is VA. Now this VA will have component along this direction. So if this angle is 60 degree, this angle will also be equal to 60 degree, isn't it? Then what happens? This component will be VA cos 60. So this is the component of velocity VA along the direction of the rod, isn't it? Similarly, this is here VB. This is the actual velocity of end B. So what happens if I take its component along the direction of this rod? then this must be VB cos 30. Now, dear students, since these 2 points are the points of the rod and the rod is rigid, so distance between these 2 points must remain same, and the distance of between these 2 points will be same if the velocities of the both the points along this line is same, isn't it? So the conclusion is this VB cos 30 must be equal to VA cos 60. This VB cos 30 must be equal to VA cos 60. So we need to find VB, and this is cos 30. VA is given as 10. Cos 60 is nothing but sin 30, because cos 90 minus theta is sin theta. And here cos 30, send it right side. So this will be cos 30. Sin 30 by cos is 10. So this will be tan 30. So this will be 10 by root 3. And if you solve this 10 by root 3, so this will be 5.8 meter per second. Because root 3 is 1.732, so it will be less than this 9.8 value. And all the remaining options are 10 or more than 10. So option C is the correct one. There are other methods as well by which you can solve this question, by taking here y x square plus y square is equal to constant. But sorry, but this is the fastest way to solve it. Next question: the x and y coordinates of a particle at any time t are given by x is equal to 5t minus 2t square and y is equal to 10t respectively. So the acceleration of particle at t is equal to 2 seconds. So for acceleration, we have to find the velocity, then differentiating it again. So velocity along x direction is given by dx by dt. So differentiating this, we will have 5 minus 2 2s are 4, 4t. Again differentiating it, we have acceleration along x direction. So this will be minus 4. Similarly, Vy is equal to dy by dt, that is 10. And if you differentiate this, you will get acceleration along y direction, that is 0. So Ay is 0, Ax is minus 4. That is the component of acceleration along y direction is 0. So there is only one component, that is Ax, and that is minus 4. So this is the answer, minus 4 meter per second square. Next, a particle has initial velocity 2i cap and acceleration, the magnitude of velocity after 10 seconds. Since this initial velocities have two components, one is along x direction and one is along y direction. So ux is given by I component is ux, that is 2, uy is 3. Similarly, ax is, that is I component, that is 0.3, and ay is, that is 0.2. We have to find the magnitude of velocity after 10x. So finding it separately. So this motion in plane is nothing but motion is straight line 2 times. You have, for finding the velocity, since it is having velocity along x direction and y direction in both the direction, so we apply the equations of motion separately along x direction and then separately along y axis. So here Vx is equal to, and the time is 10 seconds, isn't it? So by applying the equation, first equation of motion, Vx is equal to ux plus axt. So everything will be along x, time has nothing to do with x and y. So here ux is 2 plus ax is 0.3 and this is time is 10. So this will be 2 plus 3, 5 meter per second. Similarly, Vy is equal to uy, that is 3 plus 0.2 into 10. So this will be Vy is equal to, that is again 5, isn't it? So the velocity is given by Vx I cap plus Vy j cap. So this is 5 I cap plus 5 j cap. So this is in the vector form. But here if you observe, here it is given the magnitude. So finding its magnitude. So magnitude is nothing but square of I component plus square of j component. That is 5 square plus 5 square. So this will be 5 root 2 meter per second. So the answer is 5 root 2 units. It means that it may have kilometer per hour and it may have meter per second, but actually the time is in seconds, so we can assume that the velocity is in meter per second. So 19th question is, a bullet is fired from a gun at a speed of 280 meter per second in the direction 30 degree above the horizontal. So this is the condition. This is the ground, and since bullet is fired by making angle 30 degrees, so it will follow parabolic path, that is projectile motion, and the angle, here the angle is given as 30 degree. So this angle, dear students, this angle is given as 30 degree. Its initial velocity is given as 280 meter per second. The maximum height attained by the bullet is, so the maximum height, so this is maximum height h. So we have the formula h is equal to u square sine square theta by 2g. Here u is 280, so this is 280 square, that is 280 into 280. Then sine 30 square, so sine 30 is 1 by 2, its square is 1 by 4. Then divide by 2g, that is 2 into 10. Sorry, g is given as 9.8. So this is 9.8. So this is 4 ones are, and this is 470. So this is again 2 ones are, this is 140. So this will be 140 into 70 divided by 9.8. So you can find the approximate value, because these are the values which are not so much close to each other. So instead of taking g is equal to 9.8, I suggest you to take g is equal to 10, so that you can find the nearby value to these options, and the solution will be more easy. So 140 into 70 by 10, so this will be cancelled, and 14 7 is 7 4 is 28 to 9, this is 980 meter. So the option is 1000 meter. Why? Because if you are dividing by 10 and you get this value 980. If that, and if you divide it by 9.8, that is denominator is becoming less, so the value will become more. So the value will be must be more than 980 and near to the 980. That is only one option, that is 1000 meter. So this is the answer, isn't it? So don't mesh with such kinds of calculations, na. Just use the trick. Now next is, a ball is projected with velocity 10 meter per second at an angle of 60 degree with the vertical direction. It is speed at the highest point of its trajectory. Again, the question is given as the ball is projected, so it must follow parabolic path. So here the angle is given. This is suppose y-axis, so that its initial velocity is making an angle of 60 degree with the vertical, and this is given as 10 meter per second. So we have to find its speed at the highest point of the trajectory will be. So dear students, what happens now? This ball will have two components. So this is one component and this is second component. So if you talk about this component, then this will be 10 sine 60, and this is the component adjacent to angle 60, so this will be 10 cos 60. Component, suppose if I take here 30 degree, then it will be 10 cos 30, then it will be become 10 sin 30. Always the component adjacent to the angle is the cos component, and perpendicular to the cos component we have sin component. So what we have learned, that at the highest point, this 10 sin 60, that is the horizontal component of velocity, will remain same. As we have seen earlier, there is no acceleration along horizontal direction, because we assume a resistance to be negligible, and the vertical component becomes 0 at the highest point, because as the ball or any object rises, actually you have thrown something and it is being rising. So what happens now, its vertical component of velocity is getting gradually decreases, and finally it is having value 0 at the highest point, and then due to gravity it again falls downwards. So its velocity along vertical direction being increasing along vertically downward direction, but its horizontal component remains same, that is equal to 10 sine 60, and sine 60 is nothing but root 3 by 2, so this will be 5 root 3. So this is the answer. Next, the speed of projectile at its maximum height is half of its initial speed. Again, so its initial, so the speed or lesson, again, this is, let us suppose u, this is angle theta, and this is u cos theta. At the maximum height, the speed is u cos theta, because the vertical component is 0, and as you know, the horizontal component is being same. at all the points of the projectile motion, the angle of projection is. So u cos theta is must be equal to the speed of projectile at its maximum height is half of the. So at maximum height the speed is u cos theta and it is half of the initial speed. So initial speed is u, it's half. So u gets cancelled. Cos theta is equal to 1 by 2 since so theta is equal to 60 degree because cos 60 is 1 by 2. So theta is equal to 60 degree because cos theta is 1 by 2. Hai na? So cos 60 is 1 by 2. A projectile is fired from the surface of the earth with a velocity of 5 meter per second and angle delta with the horizontal. Okay, another projectile fired from another planet with a velocity of 3 meter per second at the same angle. So the delta is same for both, follows the trajectory which is identical with the trajectory of the projectile fired from the earth. So there is a different planet and there is a planet earth. The projectiles are being thrown from the earth and on that a new planet somewhere. Condition given is such that the projectile is thrown at the earth with a speed of 5 meter per second and at that planet at the speed of 3 meter per second, but their trajectories are being same. If their trajectories are being same, then their height, their range must be same. So and we have to find the value of acceleration due to gravity on the planet is. So what should be the value of gravity on that planet so that their range and their height of the projectile must be same, although the initial velocity in both the cases is different. Both the cases are different, isn't it? So let us suppose I am finding the expression for height of the projectile which is being thrown on the earth planet. So it is initial velocity is 5. So first formula is u square sin square delta by 2g. So here u is 5 square sin square delta by 2g. So HE is equal to 25 by 2g sine square delta. And on some other planet, that is HP, the velocity is 3 square, delta is same, and 2g dash, acceleration due to gravity is g dash. Now it is given in the question, since the trajectory is identical, that is, it means that HE must be equal to HP. So what we get, this is 25 by 2g sine square delta is equal to 3 square, that is 9 sine square delta by 2g dash. This 2 gets cancelled. Sine square delta cancel, and this g dash, isn't it? This g dash here, this is g dash. So this g dash is given by, this is 9 into g divided by 25. So this will be 9g by 25. So this is the answer. G is equal to 9.8. Again, since the options are not very much close to each other, so to find the approximate value, take this as 9 into 10. This is 25. So 9 tens are 90 by 25. So 25 threes are 75. So it is somewhere nearly equal to 3 point something, isn't it? So this is the solution. Next, the horizontal range and maximum height of a projectile are equal. The horizontal range and maximum height, so this is range, this is height, are equal. The angle of projection of the projectile is, so the expression for height is u square sin square theta by 2g is equal to, the expression for range is u square sin 2 theta by g, u square sin 2 theta. So sin 2 theta is given by 2 sin theta cos theta by g. So this g gets cancelled, sin square theta, 1 sin theta gets cancelled, u square cancel. So sin theta by cos theta is tan theta. Now take cos theta left side, this 2 becomes 4, and this theta is tan inverse 4. So this is the solution, dear student. Theta is tan inverse 4. So here it is the answer. Next, given that projectile is fired at an angle of 45 degrees with the horizontal elevation angle of the projectile at its highest point. Since it is given that, so let us first analyze the situation. Here it is projectile, and it is its highest point. Let us suppose this is point P. Now you have to find the angle of elevation from the initial point, as seen from the initial point. So here, this is the line. So this angle is angle of elevation. Now if you join this side, so this is h and this will be, since the whole distance is r, so this will be r by 2. So angle of elevation is nothing but tan alpha is equal to this h by r by 2. This alpha is angle of elevation, so this is 2h by r. Now putting the values, so 2h is 2 into h is u square sine square theta by 2g divided by r. So this will be r is equal to u square sine 2 theta by g. So this will be g and this will be u square sine 2 theta. Because it is in denominator, so reciprocal, take the reciprocal. So g gets cancelled, 2 gets cancelled, u square gets cancelled. So sine 2 theta, theta is 45 degrees, so sine 2 theta, that is sine 2 into 45, sine 90 is 1. And here sine square theta, so sine theta, that is theta 45 degrees, sine 45 is 1 by root 2. So its square is 1 by root 2 square, and this will be tan alpha is 1 by 2. Tan alpha is 1 by 2, so alpha is equal to tan inverse 1 by 2. So this is the answer. Tan inverse 1 by 2. This is the answer. Next, a missile is fired for maximum range. Since it is fired for maximum range, so the angle of projection should be 45 degree. Only then the range will be maximum. With an initial velocity of 20 meter per second, so initial velocity is 20 meter per second. G is given as 10, the range of missile. So the range is given by u cos theta. So direct apply the formula u square by g, because u square sine 2 theta by z is there. So sine 2 theta becomes maximum because theta is equal to 45 degrees. So this will be 20 into 20 divided by 10, 2. So this is 40 meter. This is the answer. Next, for angles of projection, listen, whenever you throw the same object with different angles of projection and the angles of projections are complementary, that is their sum is 90 degree, such as in this case 45 degree minus theta plus 45 degree plus theta. So if you solve this, you get 90 degrees. So these two angles are pair of complementary angles, so their range must be equal, so their ratio must be same, equal, that is 1:1. This is the special case. The maximum range of a gun of horizontal terrain is 16 km. So the maximum range is given as 16 km. The muzzle velocity of a shell must be. So you have to find. So the maximum range, that is r, is equal to, for maximum range it must be thrown at an angle of 45 degrees. So r is given by u square by g. You have to find the muzzle velocity. So this u square is equal to r multiplied by g. So r is given as 16 km, that is 16 into 1000 meter into g. G is 10. So this will be u is equal to root over this value. So this will be 16 into 10 to the power 4. So u is equal to 4 into 10 to the power 2. That is equal to 400 meter per second. So this is the answer, 400 meter per second. Next, let omega 1, omega 2 and omega 3 be the angular speed of second hand, minute hand and hour hand of a smoothly running analog clock. X1, X2 and X3 are their respective angular distances in 1 minute. So listen, what happens that time is fixed for all the cases. Time is 1 minute. And what is time actually? What is time? So time is given by theta by omega is time. Angular distance by angular speed is time. So here the angular distance is given as x1 by omega 1, then x2 by omega 2 and then x3 by omega 3, because time is same, 1 minute. Now if you find the same time for second hand, then the angular displacement of second hand, this is the angular speed of second hand, must be same. If you find, since the time is 1 minute, so angular distance of minute hand by angular speed of minute hand, so the ratio of two will be same, that is x1 by omega 1. So option 1 will be correct. Reciprocal it. So we will get omega 1 by x1, omega 2 by x2 and omega 3 by x3. That's all. Next, a particle moving with uniform speed in a circular path. So since, as you know, a particle is moving with uniform speed. So since its speed is uniform but its velocity keeps changing. Why? Because the direction of motion is continuously changing. At each point the direction is different. And the direction of acceleration is towards the center, that is known as centripetal acceleration. But if you plot this acceleration in xy axis, so the direction of acceleration is also changing. So both are changing, varying velocity and varying acceleration. Though the magnitude of both the things, that is both the velocity and acceleration, their magnitude are constant, not changing, but their direction keeps on changing. That's why we say velocity is varying, acceleration is varying, because velocity is a vector quantity. If any of the two things, that is either magnitude or direction, if any changes, then we can say that velocity is changing. A particle moving in a circle of radius r with a uniform speed takes a time t to complete one revolution. If this particle was projected with the same speed at an angle theta to the horizontal, so speed is given by, so it covers, complete the circle by time t, so this will be 2 pi r by time t. It is given a particle moving in a circle of radius r with the uniform speed takes a time t, so the speed is given by distance by time. So if it completes one revolution, then its distance is circumference, that is given by 2 pi r by t. And with this velocity, it is being thrown, it is being projected at an angle theta to the horizontal. The maximum height attained by it equals to 4r. So maximum height is 4 times range, it is given. The angle of projection theta is then given by, so we have to find the angle of projection. Listen, you have to first analyze the options in such cases. In all the options, you are observing that two quantities tr, 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 in all the options they are present. It means that here we will keep the r as it is and we will keep the t as it is. We can only change, that is h, isn't it? So h, I am changing h. So h is given by, as we all know, u squared sine squared theta by 2g. So this is, and since here u is equal to v because it is being thrown at the velocity v, so v square sine square theta by 2g is equal to 4 times r. Don't use the formula for r, because why? Because here if you observe, all the options have the variable r, that is representing range. If you write the expression of r, then r you will then the term r will, removed from your final expression and no option matches your answer. So first, therefore in MCQs it is important that you analyze the options, isn't it? So solve it. So here put the the value of v is 2 pi r by t. So here we have 2 pi r by t whole square. This is sine squared theta by 2g is equal to 4r. So implies that 2 square is, this is 4 pi square r square by t square is equal to, sorry, sine squared theta by 2g is equal to 4r. So here 4 gets cancelled, 1r gets cancelled, and finally we have sine squared theta is equal to 2gt square, 2gt square divided by pi square r. Pi square r implies that sine theta is equal to 2gt square by pi square r power 1 by 2 implies that theta is equal to sine inverse 2gt square by pi square r power 1 by 2. So the option is sine inverse 2gt square by pi square r. So option D is the correct. Next. An electric fan has blades of length 30 centimeter measured from the axis of rotation Listen, if the fan is rotating at 120 revolution per minute, so it is find it frequency is given as 120 revolution per minute. So in seconds, this is 2 rps, isn't it? So what is angular speed? That is 2 pi into frequency. So this is 2 pi into 2, that is 4 pi radian per second, because one revolution means 2 pi radian. Acceleration of the point on the tip of the blade. So here it is blade, and it keeps on moving like this. So this distance is given by the length of the blade, that is 30 centimeter, is nothing but 0.3 meter. So this point is following the circular path. We have with a uniform speed, it is having uniform speed, so its acceleration is given by a is equal to omega square into this length, that is omega square r. This length is nothing but radius of the circular path followed by this particle. So this will be omega is 4 pi square into 0.3. So this will be 16 pi square into 0.3. So this is the answer, but we have to convert it, isn't it? So this will be 16 into 3, that is 4.8, and pi square is nothing but 3.14 square. So this 4.8 into 3.14 into 3.14. So take its approximate value if you can find, that is 5 3 is a 15 and 15 3 is a 45. So this will become near to, that is 47.4 meter per second, because this will not be more than 50, isn't it, and not less than 40. So this is the answer, option B, isn't it? So next, so dear student, that's all for this lecture. Thank you. In the next lecture, we will start a new chapter, that is force and laws of motion. Till then, keep study, keep doing hard work. All the best.